Let's look at problem 15, weighted sum of a tree. In this video, we are going to solve this problem using traversal along node parent chain. It's basically chaining. You will see that the mechanism and the implementation is the same as the find method in union find treatment. For your information, you can check out our union find playlist in this channel so that you can gain some context. So this is the one part. Another part is that we are going to use cache to accelerate this the overall process when we solve this problem. So here, let me first read through the problem statement so that we can digest the requirement of the problem. So here we are given an integer array called parents, where the index is the node, and the corresponding value will be its father or parent, direct parent. So the tree root is at node 0. The parent is identified as -1, right? So we also given an array nums of the same length m, where nums I denotes the value of node I. So here we want to return a sum, where the sum is the weight of all nodes in the tree. The weight of a node is defined as this. The value corresponds to this node and times the depth minus the weight is the h is the height, so minus the depth, then plus 1. So here are the definitions of depths and the heights. The depth of a node is the number of nodes on the path from the root to that node, inclusive, with the root having depth 1. And the height of a tree is the maximum depth among all nodes in this tree. So here, if you see this example, you can see node 0 has depth 1, and 1 to 3 has depth 2, and 4, 5 have depth 3. So the height will be 3, right? So then you can just accumulate the sum, aggregate them to get the final output 37. So you can also analyze example 2. For example, 0 have depth 1, 1 has depth 2, and 2 have 3, 3 has 4, and then you can try to sum them. So here the constraints, the first one is on the problem size, and this one and this one, and also this one are for consistency assumptions. The last one means the value is strictly positive. And the input is generated such that the array parent represents a valid tree rooted at node 0, right? So here the data structure we're going to work with is this one, the list, right? So we want to find the given each node, we want to retrieve above along the node parent chain so that we can get the depth. In this procedure, we also don't want to repeat our computations. Therefore, we use cache. Let me first get the length of this parent. So this will save us some typing. So first, I'm going to write a function so that for each node, I can compute the depth. So here, I want to get a cache, which is a dictionary. So then I can see the root node have depth 1. Then the function, I will define it as fi. So the role of this function is to, for each node, yield or get its depth. So for this, we are going to use recursion. First, if I in cache, so we just return cache I, right? Otherwise, what we do cache I, it will be 1 plus same function applied to parent this node, right? Then we return cache I. So this step is exactly the implementation of find method in UniFind. So here, I mean, you exactly, I mean, if you use recursion, right? Essentially, this is a traversal along the node parent chain. So once we have this function, so what we can do is this. So for I in range M, so we call this function. So we call this function I. So this function will modify this dictionary. So after you, if a node has already got its steps, it will just directly do a lookup, right? So after this one, so you can print out this cache. For example, for this one, 0 will have depth 1, and 1, 2, 3, 1, 2, 3 have depth 2, and 3 and 5 have depth 3. So if you look at example 2, so 0 has depth 1, and 1 has 2, 2 has 3, 3 has 4, right? So we have all the information. So what we are going to do now first is find the height. So max, so cache values. So we want to find the maximum. Then we can prepare the return. So you can do like this, right? So for I in range M. So what you are going to do is result by the width, so which is defined as this, times height minus cache I plus 1. So you can return this result. That's the full solution. So actually it's very clean, right? So you get the length, you get cache, then you do this list function, do the work, and then you just return. Let me run. It passes the two test cases. So now let's look at the generic case. Yeah, it passes the generic case. So for this part, here you can use one line, right? So you can use comprehension, return sum nums I times h minus cache I plus 1 for I in range n, right? So if we run and we submit, it will be the same, but you have much compact code. So here, I guess if you practice quite a lot on UniFind, you can quickly identify the pattern, and then you just traverse along the node parent chain. In other words, chaining, right? So that's the key part for this problem. But then come back to this function. There are a lot of different ways to do this. You can do recursion, or you can use a while loop, and each time you just update I to be parent I, right? So each time you increment by 1. So with that said, I guess that's it for the current problem. Thank you for watching.